Before we get started with the video, there are two important things I would like to mention. First, I would like to thank Pranav for hosting this session with me. He has created a really useful website called CI Grade Thresholds where you can sort past papers in a variety of ways to suit your preparation. Secondly, throughout this session, we have referred to a PDF of challenging questions from a great website. They offer a range of subscriptions, including their A-level Launchpad pack, which covers pure one and statistics. You can also use the code GUIDERGEN to get 30% off for the next 2 months. In addition, they offer a subscription called PaperSmith, which allows you to generate fully customized practice papers. You can use the code GUIDERGENPS to get 30% off this as well. Now let's get started.
Noted, Excel.
Okay, yeah, so we'll wait for like 2-3 minutes, I guess.
Also, to answer the person in the chat, we're not going to just solve questions, we're going to explain things that you might struggle with.
Yeah. Okay, so I think we'll get started now.
Yeah.
Alright, so we'll be starting with the comparatively easier questions first. So initially we'll go through functions and everything, and then we'll move on to the other topics. So most of this is um, kind of easy to solve, but yeah, just like as a warm up. Okay, so you have two functions, f of x and g of x over here, and you have to find an expression for gf of x. So that's just you input f of x into g of x. So x plus 1 over x, which would be a into x plus 1 over x plus 1. You don't really have to simplify this, it's fine if you leave it in this form. Now part B, given that gf of 2 is equal to 1, find the value of a. So input 2 into, it's basically you're inputting f of 2 into g of x. So you can find out f of 2 first by doing um, 2 plus 1 over 2, okay, which is 5 over 2. And then you would input that into g of x. So g of 5 over 2 is equal to 11. So a into 5 over 2 plus 1 is equal to 11. Get a into 5 over 2 is equal to 10. So a is just equal to 20 over 5, which is 4. Okay. Wait, just let me open the chat with my phone so that I can see if anyone has any doubts. Okay, yeah, moving on. Now, given the graph of y is equal to f of x has a minimum point at x is equal to 1, explain whether or not the function has an inverse. So first of all, you have to look at the domain of your f of x. Okay, this is basically a sort of a rational function. Okay, and the domain for this is x is greater than 1. So you can start by making a rough sketch of it. You don't really know how it's going to be like. I mean, you do, but then just to get an idea, you can make one here. So when x is greater than 0, this is x is equal to 0. Everything to the right of x is equal to 0 is acceptable. And then they're saying that there's a minimum point at x is equal to 1, right? So somewhere over here would be x is equal to 1, which would be your minimum point. And it would just sort of go to the minimum at x is equal to 1 and then go up. So if you look at this graph over here, it won't be, it won't have an inverse because it's not a one-to-one function. So like the condition to have a inverse function is that the function must be one-to-one. So you can just simply say um this function is not one-to-one. Okay. Uh, if any of you have a doubt in this, I would just say open up Desmos or GeoGebra. You'll get a better idea that way. Okay. Now moving on. It is given instead that a is 5, and you have to find and simplify an expression for this. So you have to find out g inverse of x separately, and then input f of x into that. So we know that g of x is this, and a is given as 5, right? So just start by noting everything you know. 5x plus 1. So finding the inverse is pretty easy. Again, x is equal to 5y plus 1. X minus 1 over 5 is the inverse function. Now you input f of x into this. Now f of x is just x plus 1 over x. So you just do x plus 1 over x, and that is plus 1 over x minus 1 the whole divided by 5. It's better if you simplify this, okay? Because they have stated that simplify an expression for it. So this is just x over 5 plus 1 over 5x minus 1 over 5. Make it the common mm, denominator and then just do x square plus 1 minus x over 5x. And that is your final answer. So yeah, it's pretty simple till now. Okay, now moving on to these type of questions. So explain why the composite function f g of x cannot be formed. So you'll have to look at the domain and range for both the functions to um, actually get the answer. So usually the logic for composite functions is that the range of the inner function must fit in the domain of the outer function. So you have to check whether the range of g of x um, is restricted to the domain of f of x. Okay, so range of g of x must be in the domain of f of x. Because again, you're basically inputting g of x into f of x, right? So whatever the output values for g of x are, they must be valid or they must be basically restricted. So now look at the range and domain of everything. The domain for f of x is that x must be greater than 0, right? Which is your outer function. And the range for g of x is that it's all real numbers. So it's basically not restricted to the domain of the um, outer function. So let me just, must be in domain of f of x, which is not the case. Okay, yeah, so that's pretty much it for this. Now I'll just stop streaming.
Right, so I'll solve the second question.
Yeah,
Is my screen visible?
yep.
Okay. So for these questions with transformations, you want to look at the initial, the first function, and then this function you're trying to get to, and devise like a step-by-step path that can get you from this to this. So that would be from root x, you could go to root x plus 2 first, and then you could go to 3 root x plus 2, and then after that, the final g of x. So in each step here, you want to add one thing that makes it closer to becoming g of x, and then translate each of these into actual transformations. So this would be a translation like this, because plus 2 means a translation to the left, and then this would be a stretch in the vertical direction, factor 3, and then this would be you subtract 5, so that would be a translation like this. And they haven't said how many transformations we have to make, so we can say this is the first one, this is the second one, and this is the third one. But there's also one way to simplify this by turning it into two transformations. Wait, can I ask questions, or will no one answer?
Um, I mean, you can still ask. It's fine.
Okay. Does anyone know how you could turn it into two transformations instead of one? Okay, what's your answer? You didn't have to spend another 10 seconds saying that. You could have just answered. Minus 2 minus 5 is, I think, wrong.
It depends on the order, right? If you do a vertical stretch first,
Oh, yeah, yeah, no, yeah, that's right. If you do the stretch first, then it's that. If you do the stretch second, then it's wrong. Okay. So it, yeah, as Gaidru said, it depends on the order. One thing you could do is stretch first, and then after that you have 3 root x, and then now you could apply your transformation, your translation, and then it becomes minus 2 minus 5 for the second step. And the other thing you could do is go from root x to root x plus 2 minus 5 over 3. This would be a translation minus 2 minus 5 over 3. And then as the second step, you could stretch vertically factor 3. So these are different ways that you could do this. As long as your final result is g of x, then your answer is correct. You could even write it as three transformations instead of two. Either way, you get marks, because in this question they didn't say it has to be only two transformations. Okay, next, y equals inverse. Okay, so for all of these inverse drawing questions, you have to start by drawing um, the mirror line, which is the line y equals x, and now you just have to reflect this function about this line. And it'll be something like this. No, yeah. So you have to first draw this dotted mirror line. If they don't see this, sometimes you can lose marks. So you have to leave in the mirror line, and then you have to reflect this across this line. Okay. No questions? G of x is 3 root x plus 2 minus 5. Now to find the inverse of a function, you let y equal whatever the expression is. And then from this you solve for x. So you get 3 root x plus 2 equals y plus 5. Root x plus 2 is 1/3 y plus 5. So then x plus 2 is the square of this, and x is 5 plus 5 over 3 minus 2. Right? So then f inverse of x, no, g inverse of x, you just take this expression and put y in, put x instead of y. So you get this is the answer. And then you know that the range of an inverse function is just the domain of the original function. So this should be the same as the domain of g. And we know that g of x is 3 root x plus 2 minus 5. And for this function to be valid, whatever's inside this square root has to be not negative, because the square root of a negative number, we don't know what it is. So x plus 2 has to be greater than or equal to 0, meaning x is greater than or equal to negative 2. And then turn this into the range of this function. So this is the answer. And mm, okay, for this, it's just g inverse of h of 4. Do we simplify what? What's your question? Well, you could if you want, but they didn't say you have to simplify it. Plus, it's a 2-mark question, so you don't need to. Anyways, so for this question, you start by finding h of 4. So 4 minus 2, and then g inverse of 2. Now plug in the equation for the inverse of g. It's 5 over 3 squared. Okay, so this is 7/3 squared minus 2, which is 49 over 9 minus 18 over 9, which is 31 over 9.
Okay, sorry about that. Wait, is my screen visible?
Yes.
Okay. Um, so moving on to question 10. So the diagram shows a circle with this equation. You have tangents touching the circle at points B and C. By letting the equation of a tangent be this, you have to find the two possible values of m. So basically, the tangent equation is intersecting the circle at only one point. So you could start by finding out the equation of the intersections. So that's pretty simple. You just input this equation over here into y square. So plus mx plus 10, the whole square is 20 uh, x square plus m square x square. And yeah, you just basically expand this thing over here, 20, and take everything to one side. So yeah, you can factorize this part. So m square plus 1, the whole x square, uh, plus 20 mx plus 80 is 0. And uh, basically whatever the tangent is, um, no matter what the tangent is, it basically intersects the circle only once. So the discriminant of your equation of the intersection uh, is equal to 0 because there's only one intersection. So b square, which is 20m the whole square, minus 4 ac is equal to 0. There is not enough space. Right? Um, so 400m square is 4 into minus 320m square minus 320 is 0. Um, 400 minus 320, that's just 80. So m square is 320 over 80. 32 over 8, that's just 4. So m square is equal to 4. And then 8. So you end up getting, uh, because it's square, so you'll take the plus minus root of this. So m is either equal to plus 2 or minus 2. So that's your final answer. Okay. Now you just find the coordinates of B and C, right? So just to save time, keep in mind that the y coordinate of B and C would basically be the same because of symmetry. Um, and yeah, uh, technically because of symmetry, if you get one coordinate of one of the points, sorry, the x coordinate of one of the points, the other point would have the negative of that because of symmetry. But okay, I'll just do this. So using this equation over here, because that's the equation for your intersection. So m square plus 1, that's just 4 plus 1, 5x square. Um, I'm using m is equal to 2 in this case. So plus 40x plus 80 is 0. And from that, you get x is minus 4, right? X is minus 4. Um, Now the other coordinate should be 4, but yeah, let me just double check that. So basically you'd have the same equation, but it would be minus 40 because uh, in that case it's just m, right, for the coefficient of x. So 5x square minus 40x plus 80, and you get x has 4. And then for the y coordinate, you input uh, yeah, so you input this into mx plus 10. Um, Wait, this was for ms2, right? So 2 into minus 4 plus 10, and you get 2. So y is 2, and in this case you'd have y as 2 um, as well. Okay, and now we come to this. This is again a good question. If you know the concept, then you'll find it easy. So the point D is where the circle crosses the uh, x-axis, positive x-axis, which is right over here. So basically when y is 0, so you get x square is 20. If you take the root, you'll get plus minus root 20, which is 4 into 5, so 2 root 5. So, but you consider the positive one because it's in this quadrant, right? So you get x is root of 20. That's the x coordinate of d. Um, and then you're told that find the angle BTC in degrees. Okay. So for the angle BTC, you can form a sort of a triangle, okay, and then you can apply cosine rule. Um, you have to find out this thing over here. You already know what B, C, and D are, so you can find out the lengths of all the three sides, and you can make use of cosine rule. So just to revise, uh, cosine rule is basically um, c square is a square plus b square minus 2ab cosine capital C. And if you're wondering what these letters denote, um, so if you have something like this, okay, if you have one of the angles, okay, and all the three sides, you can make use of cosine rule. So the side opposite to C, the capital C angle would be lowercase c, and then the other two sides are A and B. It doesn't matter which one. So you have to find out BDC and degrees, right? Let me just note all the three coordinates first, and then we can find out the respective lengths. So root 20 comma 0, that is the root 20 comma 0. Uh, Apart from that, you have C and B. C is C is 4 comma 2. This is C, and this is B. Wait. Hold on. Uh, yeah, I think my laptop worked out. Am I audible? Pranav?
Yes.
Okay, yeah. So B is minus 4 comma 2, and then you have C, which is 4 comma 2. Now you just find out the three lengths. So DB, BC, and DC. Wait, I don't know why this is for 3 marks. Um, I would probably go with
You want me to check the paper?
yeah, if you could, I'll go with this method till then. So just find
Okay.
yeah, so you just find out all the three sides first. So BD, okay, BC, and then you have DC. And to find out the lengths, you just use the length formula, right? Which is x1 minus x2.
The actual question is 3 marks.
Oh, okay.
Yeah.
I'm making it lengthy, maybe.
Wait,
Uh,
can you tell me the answers to A and B? I'll check.
for A, it's plus minus 2. M is plus minus 2.
Okay.
And then for B, I got 4 comma 2 and then minus 4 comma 2.
Okay. I'll see if there's anything better.
Okay,
Hmm.
yeah. Okay, so I'll just use my calci to find out the lengths. Um, no need to show the working for that. So B and D is just root of 20 plus 4 the whole square plus 2 square, okay, which is approximately 8.7050. For BC, it's minus 4 minus 4 the whole square plus 0. So for BC, I'm getting 8 as length. And then you have to find out DC. So that's just root of 4 minus root, sorry, 4 minus root 20 the whole square, and that plus 2 square. So 2.055. Okay, and you just use cosine rule after this. So keeping in mind that um, the lowercase c is the side which is opposite to the angle. Now the angle is BDC, so the side opposite to BDC would be BC. Okay, so you just do 8 square is 8.705 square plus 2.055 square minus 2. Okay, I'll just write it in this form. So this was BC, right? So BD um, DC, that times cosine BDC. Okay, and let me just do the rest in my calculator and get the final answer. Also keep in mind that your final answer must be in degrees. Okay. Um, okay. And you end up getting 63.4 degrees.
That's correct.
Oh, wait. Is it? Have they mentioned any methods for that? Or
Uh, Wait, there's one thing I wanted to show.
I'll
And
just
yes, your method is actually one of the 3 mark methods. This shouldn't be 3 marks, but yeah.
yeah.
I think the reason that they made it 3 marks is because they wanted you to use, I think, circle theorems. Because is my screen visible?
Wait, just give me a minute. It's loading. Yeah.
So they asked for the angle BDC, this angle. But we know that angles in the same segment are equal. So this will be the same as any other angle here. So these two angles are the same. And also we know that the angle at the center is double the angle at the circumference. So if we find this angle, then it's this will be double the angle that we need. So we can use any of these facts, or we could even find this angle and then use that to find this, and then use this to find this. So there's many ways to do it, but so the easiest way would be finding angle BOC and then dividing it by 2 to get this angle. And to
Okay.
find angle BOC, this is just minus 4, 2. This is 4, 2. So you can just find the distance between one of these points and the origin. So that's 2 squared plus 4 squared, which is square root of 20. Yeah. So this is square root of 20. And because they have the same coordinates, this is also the square root of 20. And we know this length is 8 because 4 minus minus 4 is 8. And then here you can do cosine rule to find this angle. And it ends up being cleaner than finding BD and CD and all that.
Yeah, that makes more sense. Okay.
Okay. Or should I show that or move on?
Um, it's up to you. Hi.
Who's the speaker? Oh, hi. Okay. So dy by dx equals this, a normal to the curve at P. Okay. So we start by finding the gradient of a tangent, which is 8 over 4 squared minus 2 times 4 minus 3 squared. Okay. So 8 over 16 is 1 half minus 10 over 2 times 4 is 8 minus 3 is 5. And then the square of that is 25. Um, and this is the same as 2 over 5. So this is 3 over 10. And then since this is the gradient of the tangent, the gradient of a normal will be minus 1 over this, which is minus 10 over 3. And using the point slope form of a line, we get y minus 3 equals minus 10 over 3 times x minus 4. And in fact, okay, yeah, so y equals minus 10 over 3x plus 40 over 3 plus 3. So y equals minus 10 over 3x plus 49 over 3. Find the rate of change of the gradient of the curve. So we are given that the gradient of the curve at any point is dy over dx, which is 8 over x squared minus 10 over 2x minus 3 squared. And the rate of change of the gradient will just be the derivative of the gradient. So we need the second derivative of y, and this is minus 16 over x cubed plus 20 times 2 um, over 2x minus 3 cubed, which is 40 over 2x minus 3 cubed minus 16 over x cubed. And then you can just plug in x equals 4. So 2 times 4 minus 3 cubed. So this is 40 over 8 minus 3 is 5, cubed is 125, minus 16 over 64. And this is 8 over 25 minus 1 over 4, which is 32 over 100, which is 0.31.
Um, for this, could you just double check once?
Yeah, I was thinking that too.
Your function, like your second derivative is right, but after that.
Hmm. Wait, all of this was wrong. Yes. Oh, okay, so this was wait, 5 minus. Okay, this was 1 over 10. So this is 1 over 10, which is minus 10, and then minus 10 here. So minus 10x plus 40 plus 3. So this is minus 10x plus 43. This is the answer. And then uh, this is the second derivative. Um,
Yeah.
yeah, 40 over 2x minus 3 cubed minus 16. 2 times 4, 5 cubed. Hmm. 32 minus 25 over 100. That's 7 over 100. This is the answer. Okay. Moving on. The curve passes through the point minus 1 q. Find the value of q. So for this, since we have dy over dx equals 8 over x cubed minus 10 over 2x minus 3 cubed. But And we have that the curve passes through the point 4, 3. Now we need to integrate this to find the equation of the curve. So y is just the integral of this, which is the integral of 8x to the power of minus 2 minus 10 times 2x to the power 2x minus 3 to the power of minus 2 and dx. So this is 8x to the power of minus 1 divided by minus 1 plus minus 10 2x minus 3 to the power of minus 1 divided by minus 1 plus 3. So this is 8 over x minus 8 over x plus 10 over 2x minus 3. So plus 5 over 2x minus 3 plus p. And then substituting the point p, we get minus 8 over 4 plus 5 over 2 times 4 minus 3 plus c equals 3. So c equals um, 3 plus 2 minus 5 over 2 times 4 minus 3 is 1. So this is 4. And c equals 4. The equation of the curve is 4 minus 8 over x plus 5 over 2x minus 3. And so at x equals minus 1, q is 4 minus 8 over minus 1 plus 5 times 2 times minus 1 minus 3, which is 4 plus 8 minus 1, which is 11. So the answer to this question is 11. Okay, it's hydrogen's question.
Okay. Um. Okay. Let me just share my screen. Okay. Is it visible? Um. Pranav, is my screen visible?
Yes, yes, it's
Okay.
visible.
Yeah. Thank you. Okay. So for this, you're given a function, a weird-looking function, and then you're told that the graph of this is shown over here, and you have to find the set of values for x, of x for which the function is decreasing. So if you just sort of um, approximate when exactly the function is decreasing, you can see that over here you have uh, like after these points the graph is basically decreasing, right? So it's definitely going to be somewhere over here for sure. So that's your first cue. So whatever your final answer is, you can double check with it. Also keep in mind that um, for this function over here, um, x is not equal to 0, because if you input 0 into the function, in that case you would get undefined, which is not acceptable. Okay, so now you have to find out when the function is decreasing. So if you have um, some sort of a curve, okay, let's say this is f of x. So over here it's definitely decreasing. Now after this point it starts increasing again, and then over here it's sort of going, uh, wait, no, even here it's positive. Um, okay, yeah, that's a bad graph. But anyway, it's decreasing like this. So your function basically decreases when the gradient of the function is negative. So keeping that in mind, you can say that it's basically decreasing when my gradient function is less than 0. Okay, you can sort of try to visualize that if you want a better idea. So we'll start by differentiating f of x. So f of x over here is 4x raised to minus 3 minus 3x raised to minus 1 plus 2. The derivative of that is minus 12 x raised to minus 4 plus 3x raised to minus 2. So you get uh, 12 over x raised to 4 plus 3 over x square is less than 0. Then just multiply by x raised to 4, and you can also divide by 3. So minus 12 plus 3x square is less than 0. Okay, so minus 4 plus x square is less than 0. You get x square is less than 4. So if you just make a sign diagram, okay, you have um, so the two important points over here is 2 and minus 2 basically, because that's when x square would be 4. Wait, hold on. Okay, so if you have your x square graph over here, let's say you have 4 over here, right? And it has to be less than 4. So this is your acceptable region. So it can only be from -2 to 2. So basically x can be from -2 to 2. That's your acceptable region. But like I mentioned, over here x is not equal to 0. Like, which would be right over here. So you would have to split this into two different inequalities. So you end up getting um, x is greater than 0, less than 2, or you can say that the other one is it's greater than -2 and less than 0. Is that correct? Um, yeah, less than 0 and greater than -2. Okay, so that's pretty much it for this part. Now we come to um, a really interesting one. So a triangle is bounded by the y-axis, the normal to the curve at the point where x is 1, and then the tangent to the curve at the point where x is -1. So initially when you read this entire thing, nothing makes sense at all. So honestly, I would just say that annotate the graph that you're given. Like, this is the main reason why you were given the graph, so that you can sort of visualize what happens. So you will make use of your graph for sure to get a rough idea, okay? So the normal to the curve at the point where x is 1, the tangent to the curve where x is -1. So you can just sort of tell that 1 would be. Oh, yeah, so you can actually find out the exact coordinates of those points using f of x. So let me do that. F of x is 4 over x raised to 3 uh, minus 3 over x plus 2. So your first point is when x is 1, okay? You will be making use of your, you know that you have to use those points anyway, because you'll have to find out the normal for when x is 1 and the tangent when x is -1. So doing f of 1, you get the coordinate 1 comma 3, okay? When you do f of -1, you get 1. So -1 comma 1. These are your two coordinates. You can just sort of uh, mark them if you want. So 1 comma 3, and you have -1 comma 1. So over here approximately. Now they're saying that using these two coordinates, first of all you form uh, the normal to the curve where x is 1. Okay, your tangent would be like this. So your normal would go something like this, right? Then you have to look at the tangent where x is minus 1. So make a rough tangent over here, and it's bounded by these two lines, and the third line is your y-axis. So wait, let me just zoom in. So the triangle you end up getting is this, uh, this, and this, and you have to find out the area of this thing if you look at it visually. Okay. Now keep in mind that um, you can do this multiple ways. Um, Personally, what I would do for this is find out the three vertices, like the 3 points of this triangle over here. And because it's not a right angle triangle, I would just use the shoelace method for this. I feel like that would be much more simpler. So this, wait, let me just mark this point differently. So this blue point over here is going to be the intersection between your two lines, and then the wait, the point over here is going to be the y-intercept of the normal of 1 comma 3, and then this one over here is going to be again the y-intercept of your tangent at minus 1 comma 1. So that's like a graphical understanding of how this question works. Now you can start by actually getting into the question. I feel like if you understand this first, then it'll be much more easier. Okay, so you know already. Oh wait, that's not a good size. Um, right. So you already know what your f prime of x is. You found that to be as minus 12 x raised to minus 4 um, plus 3 x raised to minus 2. Okay, now you can just find out the gradients at 1 and minus 1 first of all, because you need to make use of both of them. So let me use my calculator again. Times 4 plus 3 x raised to minus, and then just input um, into your calculator. Right. So annoying. Okay. So wait, wrong language. Okay. Yeah. So f prime of 1 is minus 9, and then if you do f prime of minus 1, that ends up giving you minus 9 again, which makes sense if you think about it. Like the two gradients over here must match. So that tells you you're correct so far. Now you have to make the normal to the curve at where x is 1, right? So again, using the formula, delta y is m delta x. Wait, let me see how much space I have. Not a lot. Okay. So using this coordinate, and because you have to find the normal over here, so m2 is just negative reciprocal, which is 1 over 9. Okay. So y2 minus y1 is 1 over 9 x minus 1. This is your normal equation. Okay. Next, you have to find out the tangent equation, which is at x is minus 1. So for that, you just use the gradient as minus 9, right? So 8, this is minus 1 comma 1. So over here, you use this point. So y, y2 minus 1, minus 1 is minus 9 times x plus 1. These are your two equations. Now you can find out the intersection between them by equating them. That's pretty easy. So let me do that first. And yeah, you just so it's pretty easy now. You just solve it. Let me just use my calci. Okay, we're getting pretty weird values, but anyway, let's see. Minus 98 over 82. So you get the x coordinate of the intersection as minus 49 over 41. Okay. Now you just find out the y coordinate by inputting that into either of the linear equations you have. So let me just use the normal one. So that gives you the y coordinate as okay. So now you have this coordinate, which is the intersection between the two lines. Now you find out the y-intercepts, like I said. So you just equate x to 0. So let me just write down all the points we end up getting. Comma 113 over 41. And oh, we don't have enough space. Okay. X is 0. Yeah. 1 over 9 into minus 1 plus 3. So you get 26 over 9. So 0 comma 26 over 9, and your third one from your tangent. So minus 9 times 1 plus 1, which gives you minus 8. So 0 comma minus 8. So you find basically found out your three coordinates. Now you can just use, so yeah, for this I would just use shoelace method. I'm not sure if there's any other better method for this.
Wait, can I see the area?
Um, Wait, I did not find out the area yet. Let me.
Can I see the diagram I meant?
Oh, yeah.
Which area are you trying to find?
Um, this one over here.
This is just, you can use half pH.
Um, Wait.
The left point is perpendicular to the y-axis, right? And then the other two lines lie on the y-axis.
Oh, yeah. Okay, yeah. That's the better method. I see. Thank you. Wait, hold on. Let me label the points. I'm kind of slow. Um, so this, and you have minus 49 with, oh wow, that's a bad one. Anyway, 113 over 41. Okay, so the height would be the x coordinate, which is just minus 49 over 41, and the base is just the length of this, right? So that would just be uh, this plus this. So you end up doing, oh my god, area is this thing because that's the height. So half into base into height. 6 over 9 plus 8. Oh yeah, that's much cleaner actually. I don't know why I wanted to use shoelace. 26 over 9. Okay. And that ends up, yeah, just take the modulus just in case. That gives you 2 4 0 1 upon 3 6 9. That is your final answer. Yeah. Let me just.
Okay. After this 12th question, this was the 12th question, right?
Yeah.
Yeah. Can we just move on to like something better?
Okay, yeah.
Because we've covered all the questions that we thought were hard, right?
Mm.
Or we also consider question 14?
Question 14. Oh, yeah, that's a good question also.
Okay.
You can ask.
Then I'll do question 14 and then we'll move on to the questions I sent you,
Yeah.
and then limit definition and all that.
Okay.
Okay, is my screen visible?
Um, it's loading. Yeah.
Okay. The point P lies on the line with equation y equals mx plus c, where m and c are positive integers, positive constants. So it would be like this. A curve has equation y equals minus m over x. There's a single point P on the curve such that the straight line is a tangent at P. Okay. So first we take y equals minus m over x and differentiate this. So dy over dx is m over x squared. And then now we know that y equals mx plus c is a tangent. Mm, okay. So that means m over x squared is the gradient of the tangent, which is m. So that means x squared equals 1, which means x equals plus or minus 1. Mm, okay. Mm. Wait. Okay, so from x equals plus or minus 1, you can find the y coordinate, which is minus m over x, which is minus m over minus 1 and minus m over 1. That gives y equals minus m and m. Wait, wait, hydrogen.
Yeah.
Am I missing something here? Am I like misreading the question or
No, so far you're doing it right because it's in terms of n, right? It's pretty weird.
wait? I don't think I've done this question before. It's a single point.
So far it seems right though.
Huh. Okay. But then how is there a single point?
Um, you have to wait. Consider the equation, the linear equation also.
Has to be something about this.
Yeah.
Um, but what about it? Well, we know that um, if this is okay, wait, m is positive, right? Yeah, m is positive. So, but x squared is positive. There's no contradiction, right?
Yeah, but if you like just try inputting both the um, points into the linear equation once.
Okay, wait. Solutions are minus 1m and m 1 minus m. Um, wait.
C has to be positive, so just double check
Oh,
that.
yeah, that makes sense. Okay. So here we have to try to find which point will give C as positive. So wait, okay. So if you try to sketch both of these scenarios, you know that m is greater than zero. So this point will be around minus one m like this, and then we have a positive gradient because m is greater than zero. So then the line is like this, passing through that point. Whereas for this case, we have negative m is less than zero, and m is greater than zero, obviously. So when you plot this point, you get something like this here, and then a positive gradient line. So this will be c, and this will be c because in y equals mx plus c, c is the y-intercept. So we see that in this case, we have c being less than zero. But in the question, they say c is a positive constant. So this is the solution, and we reject this solution. So the answer is minus 1m. And now the normal to the curve at P intersects the curve at Q, and the coordinates of Q in terms of M. Okay, so we know that M is the gradient of the tangent. That means minus 1 over M is the gradient of the normal. And so then Y minus Y1, which is M, equals gradient times X minus X1. So Y equals minus 1 over mx plus it plus 1 minus 1 over n plus n. This is the equation of the normal. And then we have to find where this will intersect the curve. So minus 1 over mx minus 1 over m plus m equals minus m over x. Mm, So this will be minus 1 over mx squared plus m squared minus 1 over mx plus m equals 0. If you just multiply both sides by x, you get this equation. And then you can also multiply both sides by m to remove the fractions. So x squared plus 1 minus m squared x minus m squared equals 0. And then from here, you can use the quadratic formula maybe. B squared minus 4ac is 1 minus m squared minus 4 times 1 times minus m squared, which is
The,
m to the power of 4. Did you say something?
yeah, I think the quadratic one might get a bit messy. I'm not sure.
And what are you supposed to do?
I think trying to factorize might be better in this
What is that?
for the
Oh,
roots.
yeah. Yeah, okay. This is simple then. In quadratic also works out, though this is a perfect square. Anyways, yeah, so you can factorize this by looking at the leading coefficient and this. Multiply them, you get minus m squared. And then you need two numbers where if you add them, you get 1 minus m squared. So you see that those two numbers are simply just 1 and minus m squared. Because if you add these, you get this. And then when you multiply, you get this. So this is x plus 1 times x minus m squared equals 0. And that means x equals minus 1. Wait. Or x equals m squared. we need to decide between these two answers. Um, coordinates of Q in terms of M. co- Wait, both of these answers seem possible, right?
Yeah, the normal is intersecting P and Q, right? So you found out P already.
Oh, right. Okay. Um, so I think that's it. X equals minus 1 is P. So then this is the x coordinate of Q. And then using x equals m squared, you can find the y coordinate, which is minus 1 over m times m squared plus m minus 1 over m, which is m minus 2 over m. Is this right? Yeah, okay. So the coordinates of Q are m squared, m minus 2 over m. Yeah, okay, that's it for this question. Hydrogen?
Yeah.
Okay.
Um.
Um, so since this question's over, what do we do? We can do one of those questions I sent you.
Um. Okay. Or wait. Do you think we should focus on the limit one?
Yeah, we should do that. Yeah.
Yeah. Then
Do you want? Yeah.
yeah.
Should I do that question or do you want to do it?
Um. Wait. Can you do that one?
Okay. Wait. Can you see my screen?
Yeah.
Okay. So for this question, this is one of the most conceptual questions in P1, where they test your knowledge of they test whether you understand derivatives. So these two parts are just calculation. I'll do those. Find the value of k. Uh, okay. So this is when x equals 2. So y is just 2 minus 3 times square root of 2 plus 1 plus 3. So k is 2 minus 3 times square root of 2 plus 1 plus 3. 1.268, 1.2679. Okay. Then find the gradient of AE. The gradient is just the change in y over change in x. So this is 3 minus 1.2679 divided by 3 minus 2, which is 2679 over 1.7321. Okay. Now this is the main part of the question that can throw people off. And it's not even calculation or formulas or anything. It just asks, what do you understand about the derivative? We have, I'll actually plot all of these points. A is there, B is here, E is here, D is here, and E is here. So A, B, C, E, E. Now we're given that uh, the gradients of B, E, C, E, and D, E. So that's these three lines. The gradients of these three lines are 1.97, 1.99, and 1.999. So, and they're asking what these four gradients are just about the gradient of the curve at the point E. Now, we know that the curve might be going something like this. And what they're asking for here is if you drew a tangent to the point E, so this is the point E, then if you drew a tangent to that point, they're asking what would be the gradient of that using this information. So the concept of the derivative is that the derivative of the curve is what you get when you take the gradient between 2 points on the curve and then let the 2 points get closer and closer to each other. So we have BE here, and now we move our measurement to point E because C is closer, and then we do our measurement again from a closer point from point D. And if we just keep getting closer to E like this, then we get the gradient of the curve at the point E. That's the concept of the derivative, which is called derivative, the, derivative from first principles. Or for more information, you can check resources about the limit definition of the derivative. Anyways, so what this tells you is you can see clearly that this is getting closer and closer to 2. So the four gradients will suggest that the gradient at E is 2 because the gradient approaches 2 as you get closer to the point E. Okay, yeah, that's it. Um, what should hydrogen?
Awesome. Yeah, wait, is it alright if we wrap up then?
Should be or wait, is bias is here? I
He's
mean, listening. It doesn't seem so. Oh, I know he's here. Okay, so maybe we'll cover the concept of the derivative, like the actual the limit definition. Should we or should we just wrap things up?
um. Wait, is there anyone in specific who wants to learn
Yeah.
more?
Okay. Does anyone else want the limit definition of the derivative? Anyone else who's listening? Okay. Yeah. So this is the definition of the derivative. If you have a graph of a function, let's say it's f of x, this isn't a linear function. So if you plot a point and ask what is the rate of change at this point, you can't tell because the rate of change isn't constant like for a line. For a line, you could take any 2 points, measure the rate of change, and you get the same thing. But this is a curve, so that doesn't work. This is basically like if you had the displacement time graph for a car, and then you ask at the point where the time was 2, what was the car's speed? You don't know. You have no information about the car's movement if you consider a single instant. So you can't find the car's speed because it requires 2 points in time, and you have to find the distance and the time taken to travel that distance. But in one instant, you don't have information. So to find the rate of change at this point, you consider a point that's close to this point. Like let's say this point here. This will be at x, or yeah, this will wait. Yeah, this will be at x, and then let this be x plus h, so that the distance between these two points is h in x values. So we know that the y value here is f of x, and then the y value here is f of x plus h. We can find the gradient between these 2 points, gradient of the secant line connecting these 2 points, which is this line. So it, this gradient is f of x plus h minus f of x divided by the distance between them, which is h. And then now, let's say instead of here, what if this whole system, like this point, was closer, and then this line was more like this, connecting these 2 points. And then this is smaller. Even then, the gradient would just be this. And then now you could say, let this point approach x, as in it gets closer and closer to x, but it's never actually x. So if you do that and you keep making this point closer and closer, eventually you'll just have um, the rate of change of this function at this single point, not depending on any other point. And the way that you write that in math notation is the limit as this distance between these 2 points h approaches 0, of f of x plus h minus f of x divided by h. Now this just looks like it's meaningless because I just took the gradient and then I added this one part. But I'll show you how this comes in. This becomes useful for finding the derivative. So y equals x squared. Consider this function, and we want to find dy by dx. We know already that this is 2x, but what if we didn't know that and we didn't know about power rule? We didn't know this, and we had to find the derivative of this. So you consider the gradient between 2 points, which is x plus h squared minus x squared over h, and then let the distance between the points approach 0. And then to evaluate this, you can start by expanding this x squared plus 2hx minus x squared plus h squared minus x squared over h. And you can see that x squared and x squared cancel. And then you can see that you can factor out h from the numerator. The limit as h approaches 0, h times 2x plus h divided by h. This lets you cancel this. So you get the limit as h approaches 0 of 2x plus h. And this is just saying, like, what if you had 2x plus 0.1, and then it turned into 2x plus 0.001, 2x plus 1 by 10,000, 2x plus 10 to the power minus 5. Like, this keeps getting smaller. 2x plus something really small, and it's approaching 0. So this is obviously just the same as 2x, right? Because you're adding something to 2x, but you're making that thing smaller and smaller until it's basically nothing. So this is the gradient of the tangent, or the gradient of the point connecting those two chosen, uh, the gradient of the line connecting those two chosen points as the points get closer and closer. And that is exactly the definition of the derivative. So from this we have the derivative of x squared is 2x. Okay, that's it.
Yeah, that was peak. Peak here. Yeah.
Do you want to do this for Riemann sums or do we just stop?
Yeah, I think that's
Stop.
this is,
Enough.
yeah, really good.
Okay. Yeah.
Yeah.
My throat hurts.
Although, um, I hope we can do something for that. Like, or if you want to host a session for that, that would be nice. Like,
No, I'm good. I just want to eat something and then sleep now.
yeah, same. But
Okay. Um. So bye.
yeah, thank you again. This was
There's
um
no soundboard.
no soundboard. Yeah, it's not allowed here, unfortunately. Let me just
Okay.